Hi, kids. Okay, so hopefully this is just a review, but what we're going to be doing here is eventually writing equations for lines and graphing them, and finding their slope is the first thing we're going to do here. So slope, which we use the letter M, cursive M, to describe slope, M. The slope of a line is the ratio of the vertical change, how much you rise, to the horizontal change, how much you run. And you could actually, if you had the graph of it, you could count the units for rise over the number of units that it runs to get back onto a different point on the line, and then simplify the fraction if you need to, and you'll have the slope. You can also do it with 2 points. You can say it's rise over run, which is essentially the change in y. How much does the y change? We can subtract the y values to find that out. And how much does the x change? You can subtract the x values. And it's very specifically one of the points, like this is x1 and y1, so that'll be the point number 1. And x2, y2 will be point number 2. And it doesn't matter which one you call as point number 1 and point number 2, as long as x1 and y1 both come from the same point, and x2 and y2 come from the same point. Okay? Okay, so we're going to find the slope of some of these lines, and here's one of the lines. Here's the slope of line B is what they want. Okay, so you see they do y2 minus y1 over x2 minus x1. So what have they used for point number 2? For point number 2, they've used this one right here. So that was the x coordinate of point 2, and this is the y coordinate of point 2. Okay, for the bottom one here, and we're talking about these points right here on line B. So this one is then point 1, that's the x coordinate of point 1 and the y coordinate of point 1. So if you put in y2, which is 2, right here, minus y1, which is here, negative 2, over x2, negative 1, minus x1, 4. Okay, now we resolve this. 2 minus negative 2 is the same as 2 plus 2, 4. Negative 1 minus 4 is negative 5. We've got a slope for this line of negative 4 over 5. And actually, if I was to erase my marks and just look at that in terms of how much did we rise? Oops, we rose negative 1, negative 2, negative 3, negative 4. Rising in the negative direction means a drop, right? And a run of 5. 1, 2, 3, 4, 5. So we dropped 4, we ran 5, and that's where another way you can see that 4/5. Okay, let's keep going. And let's say, what about line D? Where is line D? Line D is this right here. So what you get is we've got 2 points here, this point right here, and this point right here. What do? Okay, we say that this is point number 2. So this is x2 and y2. This is point number 1, so x1, y1. You could have done it in either direction. Either point could be point number 2 and vice versa. Okay, but anyway, you then have 0 minus negative 2 over 4 minus 4. And what you get there is 2 over 0. And division by 0 is undefined, so we call this slope undefined. Okay, and that's what we're going to call perfectly vertical lines, undefined. And we'll get to that again in a little bit. Anyway, that's how you do it. So use the graph in this first problem, and you're going to find the slope of A and find the slope of C. Good luck. All right, so we can have slopes that are either positive or negative or 0 or undefined. And the sign of the slope tells you whether the line rises or falls to the right, meaning if we go from some point to another point on this positive line, we say as the change in y is positive, we're increasing that number. The change in x is positive, we're increasing that number. So a positive over a positive gives us a positive number. Another way we could think about it would be, let me just erase that, is that what if we were going in the other direction? What if we were saying we're starting at this point and we're going to here? okay? Well, the change in y then would be negative because we're dropping, and the change in x would be negative because we're going towards negative numbers on that x-axis. So that would be a negative divided by a negative, which is also a positive. Okay, so anytime the signs are the same, it's positive, and you are rising as you go to the right. Now, what about for negative slopes? Well, as one goes up, the other goes down. So as we go in the negative direction for y, we go in the positive direction for x. Okay, so positive over negative is negative, or negative over positive is also negative. Okay, positive divided by negative, negative. Negative divided by positive, negative. So if one's increasing as the other's decreasing, that's going to be a negative slope. Zero slope, what you got is that neither one is changing for the y direction. We're not rising or falling, okay? And I kind of describe this as grandma says, how many stairs are there? How far am I going to have to go up or down? And you say, 0 stairs, grandma, because you're going flat. Okay, zero slope means 0 stairs. And what is that? That's basically a change in y of 0 over some number, which 0 divided by anything, that's a question mark, would be 0 slope. Now, undefined slope, how many stairs does grandma have to go to walk straight up the wall? Well, we don't have a definition for how many stairs grandma has to go because she can't walk up walls. Okay, undefined slope. And that's where you're dividing by 0. Some number divided by 0. That's undefined. And I have a little thing, if you were in my class, that you will know this. You have, we call slope man. Slope man looks like this. Okay, where this is positive, this is negative, this is undefined, and that is 0. Okay, slope man. And if you make the sketch of that, that might help you remember. All right, so what here we're seeing is that it says you can graph a line when you know its equation. If we have the equation of it, we can put it on the graph, and this is how you do it. By the way, the equation of a line has different forms, and here are 2 forms, slope-intercept form and point-slope form. This is where you can see the slope in there and where it intersects with the y-axis. And this one is where you have the coordinates of one of the points on the line and the slope of the line. Okay, so this looks like this, y equals mx plus b. The coefficient of x is going to be what the slope is, how much you rise and run. And this number back here is going to be where it crosses the y-axis. And if it happens to be negative, it means it's crossing the y-axis below 0, below the x-axis. Okay. If you have it in this form, point-slope form, this number is the slope. And here is the x-coordinate of the point that we could start at before rising and running. Notice that it says minus that number. So if you see x minus 3, it's 3, not negative 3. Same thing with the y-coordinate. If this is positive 2, it's actually subtracting a negative 2. So it's the opposite sign of whatever you get. And also, as you'll see, for both of these, before we can move the rise and run of whatever the slope is, we need to be starting at a point that's on the line. We're only going to be able to get back onto the line by doing this if we start at the line. Here, we know where the line crosses the y-axis, so we can start at that point, and we know we're on the line. And then you can rise and run from there to get another point and connect them. Here, you have to pull out the x-coordinate and the y-coordinate and go to that point, start there, and that's one of the points, and then you can rise and run from there to the other point that you need in order to have 2 points, and then know where the line is. Okay, so this problem is in a couple of parts. This first one, what is the graph of y equals 2/3 x plus 1? Okay, well, what we want to identify is what is the y-intercept and what is the slope. The slope is 2/3, it's the coefficient of x, and the y-intercept is 1. So that means we go here to, on the y-axis to 1, and we know that this is a point. We start there, we graph that point. So we need to have a point on the line. Then, from that point on the line, we can rise 2, run 3, which is what the slope is, get another point, and now we just connect them. Okay, and it says, what do you do first? Determine which form of the linear equation you have, because that's going to decide where you have your starting point. Okay, then use the equation to identify the slope and the starting point. Okay, so this is where we have it in point slope form. What is the graph of this point? Okay, well, let's identify what we've got. We got the slope of -2, and we've got a point that is, the x coordinate is the opposite of what we see there. We see a +3 there, so it's a -3 for x. And here we see a -3, so we have to put a +3 for the y coordinate. Okay, so we graph that point, which is -3, 3, -3, 3 right there. And then we need to move this slope. But where's the rise and run? Okay, rise and run always needs, it's a fraction. Well, we need a fraction, so a rise always needs a run. If it's a whole number, an integer value, this is -2, we put it over 1. Then we have our run of 1. Okay, so from this point that we graphed, -3, 3, we rise -2, run 1, we have a second point, and you can connect them. All right, now it's your turn. You're going to graph y equals 3x minus 4 right here. And here you're going to graph y minus 2 equals -1/3 parentheses x minus 4. See how you do. Okay, so I'm actually going to talk you through this solution. For this first one, we say we've got a y-intercept of -4. So we go down here to -4, we put a point. And then we have a slope of 3, or 3 over 1, if it's a whole number. So we rise 3, run 1, don't forget to run the 1, and you've got that point there. And now you can connect them. I always like to do it several times, because the further apart the points are, the more accurate the line is going to be. So I'm going to rise another 3, run another 1, rise another 3, run another 1, rise another 3, run another 1. If you do that, you will get a line that runs through all of them nice and neatly. I don't have a ruler, but if I connect, actually I can do this. If I connect the faraway points, then the ones close up will connect as well. So we got that. Let me line it up. There you go, like that. Okay, now let's do this one. We've got to find that starting point. So what do? We say, what is the starting point? Well, this says -4 here after x, so actually 4 is the x coordinate. And this says -2 here, so y is 2. Okay, notice that the x coordinate follows x minus here, and the y coordinate follows y minus here. So we go to 4, 2, and we can plot that point right here. And we have a slope of -1 over 3, so we can drop 1, run 3. Drop 1, run 3. And if you connect those lines, and I'm just going to adjust it, that's what you get. All right, we're going to write equations now, and it depends on what you're given, which form you're going to use. You can write an equation of a line when you know its slope and at least one point on the line. And fun fact, the y-intercept is a point. It's just we're going to use it in a different way. Okay. What is the equation of the line with slope 3 and y-intercept -5? Well, look at what we've got. We've got slope and we've got y-intercept. So we will use slope-intercept form. And this looks like that. Slope goes there, the intercept goes there, and we resolve this plus a -5 to just say -5, okay? And that's the equation. And of course, this is what it says here. Which one do you use? It depends on what you have, as I said. So what about this one? What's the equation of the line through this point, -1, 5, and slope 2? We have a point and a slope, so point slope. That looks like this, where we say y minus, and then the y coordinate, y minus 5, equals the slope of 2. And notice you put brackets here because you're putting a parentheses in when you sub this number in, okay? That's just outside parentheses, essentially. So x minus, what's the x coordinate? -1, x minus -1. That resolves to x plus 1, and that is your equation. So if you wanted to go backwards, just a fun fact, if you wanted to go backwards from this and say, what if you were given this, like in an earlier problem, how do you get the point and the slope? Well, the slope is going to be whatever you've got here in front of that parentheses. So the slope in this case is 2. But what is the point that they used? Well, we look here and say, what's the opposite of what we're seeing there? We're seeing a plus there. So it's a -1 for that x point. What are we seeing here? We're seeing a -5, so it's a +5 for y. And that agrees with what we have here, where we were given that point. Okay? So what about your got it problem? Try it. Okay, so way back in the beginning, we learned that through any 2 points, there's only one line. So if we had 2 points, we would know the line. And in fact, we can use 2 points to write an equation. Okay, now we didn't really have a formula for that, but what we did have is we can take one of the points and we can find the slope by using the 2 points. So then we would have a point and the slope, and we could use point slope form. So what does this look like? Here you go. Start by finding the slope, which if you do this, you say y2 minus y1 over x2 minus x1 gives a slope of 6 over 5, which I can verify right now by saying rise of 1, 2, 3, 4, 5, 6, run of 1, 2, 3, 4, 5. Looks good. Okay. And now it says you have the slope and you know 2 points. So you can use either one of them for point slope form. Use either point. You could also use the other one from what they did, but what do they do then? They write it here like this. Okay, you have the slope at 6/5. They say y minus the x coordinate here 5, y minus 5 equals 6/5 x minus this one of 3. And of course, for your got it problem, what if you use the other point? Okay, and you're going to rewrite them into slope-intercept form to compare this one with the one that you came up with. Now, if you are struggling with, I don't know how to write this into slope-intercept form, well, I'll tell you here, and you can ask me during office hours if you want, but you're going to distribute this through, multiply that and that both by 6 over 5. And then once you have that, you're going to add 5 to both sides to undo that. So it says y equals something x plus or minus something. And in fact, what they have written in answer B is what you would get. Okay, you know the slope of a horizontal line is 0. And remember slope man. You know the slope of a vertical line is undefined. And horizontal and vertical lines have really easy equations. You don't actually need to involve the slope in it because, in fact, what you're going to do with these equations is you're going to say, for perfectly horizontal and perfectly vertical lines, one of the coordinates is always the same. And that's how you're going to write the equation. So if you look at this and you say, for this horizontal line, we've got a point there at 2, 4. And over here we've got, let's say just any other point, we've got 3, 4 is that coordinate of that point. Well, what's always the same? The y coordinate's always the same. And what is it? It's 4. So this one has an equation of y equals 4, which you'll see in a second. Okay. And what about this vertical one? Okay, this vertical one, you can take a couple of the points and let's say plot a point, write down what it is. Here we've got one at 2, 4. We've got another one down here at, let's say, -1. I'm sorry, 2, -1. What's always the same? The x-coordinate is always the same. And what is it? It's 2. Okay. So those are the two equations, but how do you get that from here, this point? Well, you can say, first of all, you can visualize. If you wanted to write the horizontal lines always cross which axis? If I drew a horizontal line, it would cross the y-axis. So horizontal lines will have a y equals something because it crosses the y-axis. And where does it cross the y-axis? What is the y-coordinate for all of the points? It's 4. So y equals 4. Okay. Perfectly vertical lines cross the x-axis. Perfectly vertical lines will have an equation of x equals something. And it depends on what that x-coordinate is in the point that you're given. The x-coordinate that they gave us is 2. So that you're going to have an x equals 2 equation. Okay. And you can see their explanation here. I'm sorry that I'm written all over it. But as it says, every point in the horizontal line through 2, 4 has a y-coordinate of 4, so it's y equals 4. And it crosses the y-axis at 0, 4, because it has a y-coordinate of 4, and of course the x-coordinate is 0 if you don't go anywhere left or right from here and just up. Every point of a vertical line that goes through 2, 4 has an x-coordinate of 2. So the equation is x equals 2. X is 2 everywhere. And it crosses the x-axis at 2, 0. Okay, so you know that every point, including where it crosses the x-axis, is going to have an x-coordinate of 2. The other coordinate will be 0. All right, try yours. What are the equations of horizontal and vertical lines through 4, -3? And can you write the equation of a vertical line in slope-intercept form? Explain it. Think about it, and you'll be able to do this. Okay, hopefully that quick-ish review was useful for you to recall all the stuff that you learned last year in Algebra 1. Try these lesson check problems just to verify that you know exactly what's going on, and particularly stuff like this error analysis is good to make sure that you know how to catch errors.